Yeah, so good afternoon, everyone. So let's start the VISI webinar, the Master the Future of the Day Design with the VISI Progress. So today I will explain. So before that, so myself, Baswannappa Karvinor. So I am looking the VISI software from last 10 years with the Hexagon. So today I will show the complete the solution for the progressive day from part unfolding to the complete day design process. So in this agenda, so how easily we create a complete strip design with optimized layout with a complete day design process. So then I will show the one-click simulation. So how the blank simulated with a complete result like a thinning and crack. Okay, so the wrinkling. So all type of the product-related defects. So this related also I will explain today. So VZ Progress, it's a dedicated the product for the sheet metal industry, same as the plastic also. But in the today we will explain about the complete the sheet metal design process. See, in the design, the first the process is part unfolding. So whatever, if there any progress the part, so easily we can unfold with dedicated features. So then we can create a complete strip design. So in the strip design, so we can create all type of the bends, bending punches, all type of trimming, piercing. So all type of the punch profile also create in the strip design itself. So once we finalize the strip design, so the inbuilt all type of the templates available like a ASCO, DMA, Newsburger, Kutaba. Okay, so all type of the die sets available, and here we can do our own the custom template also. Once we create a template, so all type of the punch creation. So here also we have the VISI almost automatic options available. During that, you can use that option and reduce the design time. Okay. So then inbuilt all type of the standard libraries available like ASCO, Newsburger, Missimi, okay, all type of libraries available. Once we create a complete deck, so automatically we can generate the bill of material. So in the single click up. And this the bill of material we can export to the Excel format also. Once we design, so then the next picture is the VZ blank. In the VZ blank, you can generate the one-click blank development and the spring back composition surface. Then we can check the all type of the part visibility like a wrinkling. Okay, so what is the maximum minimum thinning, how much the flange force is required. So all type of how much the sharing tonnage is required. So one click we can do the simulation in the VZ itself. So before I will start with the linear unfolding. So in this demonstration, so I will show the live the process, how easily we create stages and strip design. So linear, so there are two methods, the linear unfolding and flange unfolding. So if it is a simple bend, okay, if it is a linear part, so you can approach the linear options. If there are any the flanges like a flange on curve, so if there are any connector parts, so this type of products also we can generate the complete strip design. Okay. So then once we analyze the strip design, so here we can assign the material and so how much the K factor is required. Okay, inbuilt all type of raw material data sheets available. The complete the data sheet is also completely customizable. So flange, if there are any multiple flanges, multiple bends is there, so that is also you can unfold easily using up the dedicated VISI commands. So flange on curve options is available. If there are any cylindrical part, okay, so automatically software says the number of stages based on the diameter, based on the material and height. Okay, so this is a very useful for if there are any draw parts, cylinder parts. So directly software given the stages based on the parameter. So this is the strip design. you can create a linear parts. Okay, if there are any non-linear parts. Okay, so directly we create a complete strip design with a solid part. Then we can create all type of the cutting punches. Okay, then we can assign the material. Okay, so just I will before going to the next slide. So I will show the live demonstration how easily we create stages, then strip design. So then here we can see the nesting management. So automatically software given the discard percentage based on the layout. So software automatically given the multiple layout. So here you can check the minimum utilization. Okay, so maximum utilization layout based on the nesting management. So just I will show the interface of the VISI. So just I will open the software. So see this is the software VISI. It's a dedicated product for see the welcome screen. So CAD camper for tool makers means it's a dedicated product for the tooling industries. So once I open the software, so just I will take an example how easily we create stages, then step design, then same part we can do the complete day design process. So just I will start with the basic step design process. Here I take a simple example. So this is the part. So when we start the part, so first of all, so we can assign the material based on the raw material. So automatically given the blank result. And this blank result is very accuracy up to 98, 99% we can do the accuracy. So here the options available. So these all are dedicated features. So first of all, so I assign the property. So when you can import the file format model, so directly you can assign the material. And VISI, you can open all type of file format, step, IGS, Parasolid, DXF. Other than you can open the negative file like a NX, CATIA, okay, Creo. So all type of negative file also you can directly open in the VISI software. Just I will select the part. So when I select the part, so automatically software given the sequence means the bending stages, if there are any linear, flange. So automatically as per the color coding, so automatically software will suggest the stages. Then I will assign the material here, sorry, origin. So in the below, we can see the all type of raw materials available. For example, I take a stainless steel. So in the stainless steel, so variety grades available, and this completely the material data is customizable. For example, if there any unknown material, so directly we can add the raw material. Okay. So just I will select the origin point. So then I select the material and the grade. So I select a 304. Then here you can see the if there any coining. Okay, coining pace is also searching automatically. Then here you can see the K factor. So 1/3, 1/2, 2/5, and here you can assign your own K factor also. Okay, that is the option also available here. So just I select the origin, then I click OK, and next I will define the stages. So before define the stages, just I create a blank. So one click you can generate the blank. Okay, part unfolding. Just I click the part, and you can directly create the blank. Okay, and here options available, right to left, left to right. So this we can do it. Then we can see the next stages definition. So these the options available here. The first option is step unfolding. So just I select the part. Here I click the pre-bend as a 45 degree. We can assign the bend angles based on the angles. So automatically we can unfold the part. Same side I unfold in the another side. So here I click as a 45 degree. So I will take another stage. Just I will select the bend portion, and we can add another stage here. So these are the options available here. So just you can add one more stage. So then I click this side and add one more stage. And this is the complete sequence. And in middle also you can modify the stages. For example, if there are any product changes. For example, I see just I modify this part. When I change the modification, so automatically this will reflected into entire strip design. So means this is a completely parametric associative with the complete strip design. Okay, when you change the product design, so automatically it will reflected into entire die design, then strip design as well. So then the next option is the part unfolding. Just I will show the process. Sorry, strip design. So in the strip design, so we required a blank. So already we have generated the blank here. Then I will start a strip design. So in the strip design, just I take a single layout. Either multiple options available. So if you want to mirror, otherwise multi cavity. So there is the multiple features available. Just you can utilization. If there any mirror object, if there any multi layout if required. So just I select the part and select the origin. So I start this the strip design in this location, and we can assign the path. Based on that path, you can generate the strip design. So here already we have select the material and the parameter everything. So here only we can choose the number of stages, how much stages is required. Then before origin, the strip is required, so you can give the value. And here you can mention the pitch, how much pitch is required. Then strip width, so we can assign the strip width. Okay, if you want to keep the part to part distance, you can keep the part to part distance. Otherwise, you go with the pitch also. So then stages already we are defined based on this input. So automatically software given the discard percentage. Okay. So just I click OK here. If you have any questions, so just you can use the chat window and you can type your questions after this session. So I will try to answer your all technical queries, questions. So just I will start the strip design here. Here if you want to edit the parameters, so directly you can edit during the design. And if there are any close profiles, so automatically we can add internal punches. Then there are sketch method. We can create a punch. Otherwise, we can create using the create a maximum sharing punch method. So there are two methods. So I will explain both methods. The first of all, I will explain about the sketch method. So by sketch, I create a punch here. So this is the trimming punch. And after that, directly we can add this punch into the strip design. See, this is the punch, and here you can do the simulation also, how the cutting is happening. See, so when I change the position, the punch position, so automatically strip is updated accordingly. Okay, this is the final output. Okay, so this is the first method. By sketch method, we can create a punches. Then another is the create a maximum sharing punch. So we can develop the maximum sharing punch. And here, so here you can give the all type of parameters. Okay, so you can modify the punch. Here you can give the upper and lower gap. Okay, if you want to keep overlapping, okay, so you can add overlapping in between the punch. So once we create a punch, then we can cut the punch as per the sequence. What I can do, I select the path here, then I select the direction. So just I cut this punch. Okay. If you want to keep overlapping, so you can keep the overlapping in between the punch. What I can just I cut the punch, entire punches. So whatever I will show, it is a completely live. So I will live create the complete strip design. And yeah, this is the punch. Already we have cut the entire punch in the single stage. So after that, just I will drag and drop these punches. Okay, so this punch I will transport to the next stage, and this punch, so I will transport to the last stage. Okay, so after that, just you can update the strip design, so automatically it will reflect the complete output. So then if you want to add in middle punches, then you can add the in middle punches stages also. So here you can see the insert the step. So you can add one more stage in between. So that is also possible. So then once we create a complete punches, then we can attach the stages based on the process. Okay. So this is the embossing picture. Okay. So before the trimming, so I will consider this stage. So I go to the step number 2, and this I will 6 and 7, and this I will apply to 8 number stage. Yeah, this is the complete strip design is done. Okay. So then now, so the complete operation is completed in the 10th number stage. So I don't need the another stages. So what I can do directly, I edit the stage 16 to 10. Otherwise, I mentioned 11 stages. Means in middle, we can edit the complete strip design also. So once the design is ready, then you can add the punches also. This is the dedicated features available here. Create a vending punch. Just I select the area, and we can create a punches. Then here you can see I will create the 45-degree punch. Here the options available. If you want to offset the side face, that is also possible. And same as you can create the die insert also. Only you need to change the direction, and you can generate the complete die insert also. So this is the complete strip design process. Once the strip design is ready, so here you can generate a report. So in this report, just yeah, in this report, so in this report, you can generate the complete parameter like a strip weight, strip upper and lower discard percentage, then part weight, strip weight, discard weight, and here you can see the tonnage. Tonnage is also you can calculate it automatically. Okay, so sharing tonnage, then vending tonnage. If there are any flanges is there, so that is also generated automatically. So this is the complete strip design process. Once the strip design is ready, the next process is tool build. So just I will open the complete strip design. Yeah, so this is the complete strip design. So now I will generate the complete the tool on this product. So I clicked on so here the options available, the progress tool, and this completely the template is a customizable. Okay, so based on the customer requirement, otherwise based on your own the standard, so we can do customization. So that is the one time activity. Is the moment. So this is the template, and here you can see DME, Music Burger, so multiple standards available. And just I will select the strip design. So based on the strip design, so directly we can add the templates here. See, and this is the complete template. So you can modify, you can increase the size. Okay, and this completely is customizable. For example, if you want to add some modification in the plate, the current thickness is 56, so I want to change 35. So it is a completely associated with the complete strip design. So easily we can modify the complete parameter here. And here you can see the middle, and this is also completely uh, customizable. Okay. For example, if required, if not required, the bottom plate, so directly we can delete the plate. Otherwise, if you want to do some customization, the custom plate, so that is also possible here. And once we finalize the thickness, so just we can reduce the total height, shed height. Just I will change the parameter here. So then next is topic standard auxiliaries. All type of the sheet metal and mold inbuilt the templates available. What I can do, just we select the templates here. So here you can see the progress insert element. So here I choose the supplier. So for example, I required a VISI. Okay. So I select a code. Directly you can type the code. So for example, I select a MYAP. Okay. So here input only the 2 points. One is the start plate, end plate. Then you can assign the position. So I select the start plate and then I select the end plate and I select the position. So from corner, otherwise you go with the center also. Just I select the start and end plate and automatically we can add the standard catalogs. Okay. So here you can see all type of sizes available. If you want to change a 25, okay, you can automatically it will reflected. And height also you can modify. So that is also possible. Once we add the standard, so the modeling you can mirror and you can rotate the complete the if you require multiple entity. Okay, you can mirror the complete entity here. And same thing, for example, if you required screws, dowels, so all type of the templates available here. Febro, I select a start plate, and this is the end plate and position. And this screws is generated automatically. So then diameter I will apply here. So same thing, I will apply the dowel. So start and end plate, then position. So once we create a complete standard auxiliaries, so after that you can directly do the separate element cavity. Means what happens? So once we apply that option, so automatically the counter and the relief hole so enter the cavity is generated automatically. If I change the position, so this will reflected into entire plate. For example, I change this position. Okay, consider I will change 10 mm, okay, 20 mm. So this is the option called rebuild the standard. So just apply this option. So automatically the position with the entire the sequence is also updated automatically in entire plates. So this is the complete helpful to reduce the complete design time. So next I will show the picture for the punch creation. So these the complete punches we have generated during the strip design. Okay, so now we need to add the complete the from punch plate to bottom of the day, the clearance, the collar, okay, all type of the remaining pictures we can apply. So this is the option called the punches. Just I select the picture. Just I select the entire picture. So automatically software add the complete in the list. Then we can directly extrude the entire punches. See this is generated from the punch plate to the bottom of the die. The land clearance, so these all are customizable. So these also generated automatically. Then here I take any one example. So consider this. I will take this punch. Here we can add the directly collar. So hook fixing option is there. So just I select the option and we can add the collar, and then we can apply the complete clearance. Okay, clearance means punch and the punch plate clearance, then guide plate clearance. So these all are customizable. In the CFG editor, one time you can set the entire parameter also. So then here you can see the bottom of the die. So here with the draft, so without draft, so multiple options available here. So just I required a with the draft, and here you can see the cutting length, means it is a land. Then here you can see the angle, okay, shape angle. Then you can give the additional offset here. See, means here multiple the methods available. Just you can use and create the complete the punch management. So once we create the punches, the remaining is same. So just I will use the subtract element cavity. So here you can see automatically generate the relay hole. Okay, then you can see the punch profile also. Okay, if I change the punch profile, so automatically the entire parameter is updated automatically. So this is the punch method. Okay. So next I will show the process of this is the final tool design. Here you can see this is the bottom up, and this is the top assembly. Okay. And once we create the complete the design, so the 2D drafting, so everything we can do in the same platform and with the bill of material. So this is the complete tool design. Just I will go to the plot view. So in the plot view, the option is automatically we can generate the complete 2D with the template. But here we can give the limitation options, means the dimensions. And here additional if required the dimension like a whole chart, okay, some in detail dimensions required, the pictures is available. Just I will use the template, and just I click OK. Automatically the entire the drawings, the 3D model is convert to the 2D drawings. So this is the process is done. So here you can see the complete 2D drawing, but here you can see the only the bordering dimensions we can generate. For example, dimensions, in detail dimension, and otherwise sections are required. So here some pictures available. So directly we can use this option, sir. Okay, so for example, I create a fresh drawing. Okay, I will take the template and we'll use the template. So this template is completely customizable. So this is the complete template. Just I will take a top view. And here you can see the options available, six sections. So I will take a simple sections here. And once we get the sections, and we can generate the complete bill of material. So this is the bill of material generated automatically. So during the design, so if you add any standards, so automatically the generate the complete bill of material. Just I will select the part, and you can see the ballooning. So it will generate it also automatically. And you can export this bill of material into the Excel format. Otherwise, you can keep this complete template in the our design template. Okay, so there are two method. Just you can if you require the Excel format, so directly you can export to the Excel format as well. So I generate one. So in the BOM, so we can generate the complete bill of material. Okay. So this is the point means start from the unfolding. We can generate the strip design. Okay. So I will go with the PPT. So here you can see I will explain about the nesting management. Okay. So maximum utilization you can find out. And this is the complete day template. So these all are customizable. You can do the uh, uh, custom templates also here. And so all type of standards. Okay, you can directly import all type standards directly. So here you can see Misumi, Pebro, all around 36 supplier standards available in build. And punch management. So this type of punch, collar, clearance, everything you can do customize this automatically. Okay. And then once we create the design, so we can check the all type of interface, because when we give the manufacturing, before the manufacturing, you can check all type of the clashes like collisions, all type of the weak steels. So in the design self, so we have all type of the interface checking options available. So during before design release, so just you can check the all type of the issues. So this picture is available. And once we create a complete design, so we generate the bill of material, okay, in the Excel format. So completely bill of material is automatically you can generate. And here you can assign the hardness and material. These all are customizable. Then the all type of detailed dimensions you can do it. Then the next point is blank generation and blank report creation. So before that, so I will explain about the if there any cylindrical part. Okay, so that is also you can do unfolding. So just I will take a cylindrical part here. How easily and quickly you can generate the stages. So this is the picture available here. Cylindrical draw. Just I select the part, then I select the origin and material thickness, and just I apply the thickness here. So automatically software given the stages. See how much stages required. If I change the material, the automatic stages is also changed accordingly. So these pictures are available only for the cylindrical draw. Okay. So next I will show one more picture. If there any this type of the terminal products. Okay. So here one more options available, flange unfolding. So in the flange unfolding, so directly we can develop the blank. You can see. So this picture is also very useful if there are any electrical parts. So the next picture is if there are any flanges, so multiple radius, multiple flanges is there. So that time you can use another picture called the flange unfolding. So this is the option. Just before that, I will assign the material here. So just I convert to the flange. So just I will unfold this part. Just I will apply as a warping faces this space. See, without changes, so you can directly unfold this area. Okay, means it is available in the flange. If there are any multiple radius, okay. So if there are any complex parts, so that time you can use this option. The next part is the blank development. So in the one click, we can generate the blank. Just I will take an example. So this is the complex part. So in this, when you can get the customer part, so initially you require the approximate it's the accurate sizes means the development the blank, and we can generate the all type of we can check the all type of defect like thinning, spring back, okay, spring back composition, okay. So what is the maximum, minimum thinning, stress strain? So all type of the defects you can check here. The option called VISI blank. So just I select the part here. So once we select the part, so automatically we can assign the material, and so automatically software given the minimum radius here. See, this is the blank, and here you can check the thinning. So what is the maximum, minimum thinning in the part, and we can check the simulation. Means one click you can do the simulation, and this completely simulation is recordable. Then you can check the safety zone. So where is the safe area, low strain, wrinkling tendency? Okay. So what is the maximum excessive thinning? And we can generate the every report also. So this type of you can generate the complete report. In the report, sharing tonnage, total tonnage, blank width and length. So maximum the thinning you can check here. Then you can check the FLD, means what is the maximum minimum strain, stress strain. Then we can check the spring back. Okay, spring back compensation means how much based on the raw material. So you can generate the spring back. You can see there are two different sheets available. The blue color indicator it is the nominal mesh. Then the green color it is the spring back mesh. Based on the input, so software automatically given the composition surface. Just I will show the spring back compensation sheet. Just I select the part, and here you can see the first of all I select the nominal mesh, and then I select the spring back mesh. I want to the composition in the entire plate, so that I will select the entire plate, the seat. So based on the material, based on the input, so automatically software given the composition surface. Here you can see inside software automatically given the composition sheet. If I make a complete tool based on the sheet, so we can achieve the middle result. Okay. So other than you can take a number of trials, a number of iteration, so to achieve the component result. So this is the feature during the blank development. So you can check the spring back also. Just I will start with the go with the PPT. So here you can see the VISI blank. Here you can generate the all type of report. In the next, in the current version, so incremental simulations also available. But in this webinar, so I will skip that one. But if required, so we have that solution also, incremental simulation. Yeah, thank you very much. So this is the last point. So this is the end-to-end solution. So we need your challenges. So based on your challenges, we work together. So this is the note. Just I will hand over to the Cadspro team. So yeah, over to Cadspro team. So if you have any questions in this forum, so just you can ask. So I will try to answer your technical query. Yeah, Shaktivel, over to you.
Yes, sir.
Yeah,
So, is there any
Shaktivel,
questions?
any questions?
Uh, just a minute, sir. Let them chat in box. So, is there any doubt? Kindly on your mic and you can ask the questions.
Hello? Yeah, Shaktivel, any questions?
Sir, you can check in chat box that customer is asking that how can VC
Yes,
CAD can streamline mold die and complex component manufacturing through integrated design and machining and automation.
just a moment. Just give me the moment. Okay, just give me the moment. I will check the chat window. Yeah, sir, assembly drawing, we can do it. Can we do assembly drawing stress strain for simulation? See, here we can see there are two methods. One is the one-click simulation, and another is the incremental simulation. For incremental simulation, so we create a complete the die punch and the blank holder surfaces. Based on that, we can do incremental simulation. Yeah, the another question is, can we do 3D model drawing by using a VISI? Yes, it is possible. The base version is with the 3D modeling. So in the 3D modeling, we can do the complete the product design. So all type of the sketches, model creations, all of surfacing, all type of options available. See, assembly creation is possible because the whatever the tool builder, so that is a completely associated with the interprets. Okay, and mating some alignment constant options are also available in the VC. How many types of tools can be done? Bending line is not shown. Yeah, bending line it is showing. So just you can contact to the Cadspro team. So if any the technical evaluation required, otherwise if you want to any checking in detail, so just you can contact to the Cadspro team. So they will answer all those questions. Bending lines it will shown because start point and end point both line is showing. How many types of tools can be done? So it's a completely custom template means so all type of connector products, all type of automobile products, stage tools, okay. So multi-cavity tools, all type of tools is possible. So just you can give your exact requirement. So based on that, so we'll show the in detail demonstration, one-to-one demonstration. How can VisiCAD CAM streamline? See, VisiCAD CAM, it's a both are interconnected. So the directly when we create a complete design in the VisiCAD, so automatically we can do the programming also. It's a completely interconnected with the Visi. It can generated automatic. See, automatic tools means just we need to understand. So what exactly required? Because the punch, so user inputs is required. The wherever the punch is required. Okay. See here only the advantages means we cannot cut any shortcut, cut the entire thing. So automatically we can unput the punch, the die, the punch clearance that is also generated automatically. This entire tool is not. Next, you can reduce the design time. So use up the dedicated some features. So whatever I shown the live demonstration. So that is all our dedicated features. So only the when we implemented this software, so you can reduce the total design time and accuracy. So you can take a multiple trials now. So you can reduce that. You can optimize that trials because of the accuracy of the blank result. All type of the dedicated features. The next is I said well marking the punch for the progressive tool. Any part like it is of the radius the punch is. See the outer, so we need to understand your question. But if there are any outer punches, so that is we need to assign. Based on that assign punches, so automatically the healing, the clearance will take automatically. But we need to understand the right question, so you can contact to Cadspro if required any in detail the demonstration is required. How to check bending line? Sir, bending line already it is shown in as a green color, so that is possible. But if required a detail the session, so just you can contact to Cadspro team. So I am using split cam software using but 10x cable. See, Sprit is also our hexagon product. So Sprit directly interconnected with the VISI also. So we can directly open the VISI file into the Sprit. Okay. Okay, Shaktivel. So I will try to answer all the questions, but if there any skipping, otherwise if there any in detail session is required, so just you can contact to the Shaktivel Cadspro team. So they will arrange the in detail demonstration. Yeah, Shaktivel. Shaktivel, any questions?
No, sir. So thank you for joining
So
webinar. So for all the questions, we will be sending you a mail with recording session. So if there any inquiry for VC, let us know so we can help regarding for technical queries and the sales part also. So thank you for joining webinar.
thank you all.